Now, when they test abiogenesis, they take a couple of molecules that they hypothesize were the first molecules that were used for life, and they say, well, we have to create I'm not really good with the names, but there's certain proteins that have to be made in order to create life. So they'll take 2 of these proteins and try and make 4 of the proteins. And so when they do that, they say in the papers, we did this process and we came up with 4 proteins from the beginning too. But really, they lost a lot of the 2 proteins to get the 4 proteins. And then when you read the references, they're actually adding chemicals that are purified bases from their laboratory to create the extra 2. So they're adding chemicals that technically wouldn't have existed in the prebiotic world to create this new life. And again, this requires a lot of intelligence to do this. Now, the main study that I really remembered off the top of my head, because it just absolutely blew my mind, was D-glucose. There's a certain protein for life that has to be made, and it's a way that 6 D-glucoses connect to each other to form this one protein. However, what's really interesting about this D-glucose is that out of the 6 D-glucoses that have to form with each other, there is over 1 trillion different ways that it could connect, and it can only connect one way to make this protein. If it connects any other way, this one protein will never be made. So this is one ingredient, okay, with a 999 billion chance of failure, and somehow it just accidentally happened. And then that's one ingredient, and that we have to look at this for like the 20, I think it's 20 or 22 or something like that.
Okay,
proteins
I gotta jump in on this, Jamie, because like there's so many things I don't want to be nitpicky, but some things just have to be clarified. Glucose is not a protein, it's a carbohydrate. The 6 things that you're talking about coming together are the carbon atoms that come together to form the glucose ring, and they can be in all kinds of different conformations.
Okay, so maybe that's where I'm getting it mixed up then. Okay, yeah.
Yeah, so you're asking specifically about the formation of these building blocks of life,
yes,
right?
Yes. Okay. So again, I'm still new to chemistry. Yeah. So yes, my terminology may be a little off.
I know. I didn't want to like nitpick you on that stuff, but
yeah, you're right though. You're right
a little bit.
Yeah, I want you to correct me on that because I'm still learning chemistry, and as I'm learning, it gets very complicating. But yes, the building blocks. We're looking at this building block.
So there's 2 paths that I want to go down with this. The first of all is that a lot of these things can be built using scaffolding, right? So there's types of scaffolds that ensure that whenever the formation of, if you want to say glucose, or we can talk about like nucleosides, like for DNA, which also have these kind of like chirality and these different conformational varieties. When you have a scaffold, right, a template that is like formed of like proteins, right, then every time that these are formed, they're going to be formed in the same conformation.
Okay,
right?
but hold on a second.
You're no longer rolling dice because you have a scaffold.
But see, you can't have the scaffold because that implies that someone put it there.
So that's why I wanted to say that there were 2 things I wanted to go with this. The first was talking about the scaffolding, which would address these kinds of conformations.
That says there's a designer. That would suggest a designer.
So you have to talk about the formation of the scaffold. So when we talk about these building blocks that you need, right? Like the biggest thing that you would need for the scaffold, right? The scaffold is going to be protein. That means it's going to be made of amino acids. So you need the amino acids. And luckily, we see amino acids being formed naturally, right? There's 2 lines of evidence for this. The first is meteorites. Like we see meteorites fall to Earth today. When we go and look at them, they're full of amino acids, like full of them. Like these things are forming like up in space from natural processes. And they can also form in deep sea vents, like down in the Earth. You can have like some complex organic molecules being formed in deep sea vents. But a lot of this was already formed like in the ice and dust that came together in the accretion disk for the solar system. It already contained amino acids and all kinds of complicated organic molecules. And there's a paper I read recently talking about the mechanism for how complex organic molecules can form in space, right? Like you have these molecular clouds of, carbon and various molecules. They're getting bathed in ultraviolet radiation because they're not getting protected by any kind of magnetic, sphere or anything, magnetic field. So there you see, and we can right now we can also look at spectroscopy in space. We can see that most of the carbon that we see in space, like, or maybe 20% of all the carbon, is forming these complex organic molecules. A lot of them are amino acids, which again we find in abundant amounts in meteorites up in space. So we do find amino acids. Those are the 20 things that need to come together to form the proteins. We find those building blocks naturally occurring. They're produced by natural means. And then the interesting thing.
Okay, so hold on. Wait a second though, because you said we find those amino acids today, but according to abiogenesis, they would not have existed until after life was already there, unless you want to go with, because what you're doing is you're saying, oh well, it came from space and we saw it created in the stars. Well, one, you can't prove that. You can't say, oh yeah, we got this meteorite and it has amino acids in it, because guess what? The meteorite that you're testing is in today's world where amino acids already exist. So there's a huge problem there. When you add space into the equation, you now have a bigger mystery to try and figure out, because now you're not limited to abiogenesis happening on Earth. Now you got to figure out how the amino acids were created in space, because there's your bigger problem. Now, the other thing you said was they could also come from the sea vents. However, we just talked about how water would have destroyed life before life was created. So sea vents, not an option. Your only option is to expand the problem to space, which only makes it harder to prove.
Right. So sea vents, still an option because there are hydrophobic pockets. Okay. So you have materials like lipids, right? And you said earlier that these chemicals do not naturally form into anything other than like their chemical structure. But that's not true with things like lipids and amino acids. So lipids are a kind of molecule that will come together, and other kinds of molecules do this as well. It doesn't necessarily just have to be lipids. It's just any kind of molecule that has one end that's attracted to water and one end that's repelled by water. And just a molecule that's shaped in that way will naturally form bubbles, right? The ends that attract water on the outside, the ends that repel water on the inside. And so you can have these hydrophobic bubbles. They're formed naturally. You can just introduce the chemicals into water. They'll form these without any direction or design, right? Like these things occur spontaneously. They form hydrophobic pockets that are associated with other hydrophobic chemicals, like some amino acids. But I want to make the point that
so hold on. The thing that just confusing me is that
you did say something I want to address real quick. Is that you said that these building blocks don't occur until after life, which is not true. I'm saying these complex organic molecules, these amino acids, were already present at the formation of the solar system, like before the sun even started fusing like hydrogen. These amino acids were already present in the stardust of the accretion disk, so they predate even the formation of planets.
So see, that is a major assumption, okay? Because again, to have these amino acids, you now have to have all these chemicals that didn't exist yet. So again, that's a huge circular argument. It's like, oh, we didn't have all the chemicals in the periodic table, but we had enough to make the amino acids to make life. So again, I don't think that's a valid argument for you to make. The second thing is you kept going back to the sea vents, but we clarified multiple times previously that in the prebiotic world there was no oxygen. If there's no oxygen, how is there water? Water also destroys. It's
there's
not
still
just
water.
Oxygen. Yeah, the oxygen is not the only thing that destroys.
There's not molecular oxygen in the atmosphere. There's still oxygen present in the water. It's just not in the O2 form in the air.
Right. So here's the thing. Oxygen destroys. They've verified that with the Miller-Urey experiments. They've also verified that water destroys. For example, let's say that you were to murder somebody and you threw them in the river, their DNA is going to deteriorate much faster and worse in the water, and it makes it a lot harder for the police to be able to get information from that dead body because the water is destroying the material of the human. So it's the same thing with a prebiotic world that's trying to build the human in the first place. Then you said that the life would make itself from the sea vents in these bubbles. Well, what is a bubble? A bubble is oxygen inside of the water. So explain to me what kind of bubble you're looking at here. Because if you have a bubble in the water, usually that bubble is oxygen inside of the water, and then once it gets to the top, the oxygen goes out into the atmosphere. So do you have oxygen or don't you have oxygen? What
Yeah,
kind
it
of
would
bubble
be
is
an
this?
anoxic environment in the interior of the bubble. These are not bubbles of air.
Okay, so what is the bubble of? Because in order for it to be a bubble in water, it cannot be water. You can't
Yeah,
have a
so
water
we can
bubble
observe
inside of
this right
water.
now today. You take a lipid, you put it in some water, you look at what's inside, right? It's going to be anything that was like the water is forced out, right? All of that, like during the formation of the lipid, right? You're not going to have anything on the interior, or you're going to have a lipid bilayer to where you have the water attracting side, the water repelling side, and then another layer of water repelling and then water attracting. So in that case, right, the two sides of the lipid that are water repelling are going to be end to end, and you can have any kind of hydrophilic molecule within that space in the membrane of the bubble. So that is the kind of formation that we have in our cells right now, and we have a lot of proteins and kind of chemistry that only exists within that hydrophilic or hydrophobic area where there's no water in between the membrane layer of these bubbles.
Yeah, but the thing is, like, you're trying to make it sound like this is totally easy to just happen by chance. And it's not, because these are
Yes.
extremely complex chemical structures. When you look at these chemical structures, they're extremely complex. And there's
They
trillions of
form
ways that they could.
spontaneously.
But how do you, can you prove that though? How
Yes.
do you, okay, how can you prove it in a prebiotic world? That's the
If you
question.
put a lot
Because,
of lipids in a container, they will spontaneously form these lipid bilayers. Like,
right, but you have to have lipids to do that.
yeah, it's just
That's what
the
I'm saying.
chemical properties of the molecule that dictate the kind of structures that they form. And with the protein equivalent would be amyloids. So proteins will like clump, and this happens with like as you get older, just the proteins that are existing in your body will clump together and form amyloids. It's like a plaque in your brain. Like these, they naturally will form from like any kind of proteins. It does. You don't need a specific sequence. You don't need specific types. Like most kind of amino acids will form amyloids. Like it'll clump together like that.
But see, here's the problem though. You already have the proteins, you already have the lipids. Abiogenesis is trying to explain how all of this came about to make life in the first place. And your only answer is they were already made in the stars and they somehow came to Earth.
Well,
And
I
then
just
all of this
explained
stuff
how
started
these building
happening.
blocks are observed like naturally occurring. Like we know amino
But that's the
acids are
thing. You
naturally
can't
occurring.
observe a prebiotic world in a post-biotic world. Like, we're in the biotic world right now. So everything you observe today is not the same as the prebiotic world.
Well, an
That's what I'm saying.
asteroid, there's no life on an asteroid, right? Like so there's no life that's creating these amino acids. When we observe them
Well,
on
that's not
asteroids,
100% sure though, because look here. Now, here's something you may not know about the creation model. According to the creation model, the fountains of the deep broke open and shot tons of pieces of rock up into the sky, and that's where you see the shotgun pattern on the moon. All of these rocks that from the fountains of the deep breaking open during the Great Flood, they would have gone out into space, and now you have all of these molecules in space. So that could be the answer to where all of these chemicals that we see on asteroids come from, because according to the creation model, the asteroids are just a byproduct of the global flood, which means that it came from Earth that was already created. Now, your theory is saying, oh, no, there was no flood, so we can't use that answer. So you're just having to say, oh, it was somehow created in a star. But you can't prove that, just like I can't prove that all asteroids come from the global flood. But see, this is the problem, though, is you're trying to, there's a line between science and our foundation, our religion, our faith.
so
And what
I'm
you're
not
trying to
saying
do
so
what
I'm
you're
not
trying to do
saying that.
is you're trying to keep the line solid on my side of the interpretation, but you want to erase the line on your side of the interpretation, and you can't do that.
So I'm not saying that like life or these things or like the building blocks were formed in stars, right? They're formed in like like molecular clouds of like molecules, right? We can see that. We don't have to just look at only asteroids that would have in your model come from the Earth, right? Not all the stars and all the nebulas and all of the gas in the whole universe came from the Earth from the flood, right? So we can look at other areas that are outside of our solar system, outside of our galaxy, and we can go and look at like molecular clouds, and we can look at spectroscopy, look at the ones that are containing carbon, and we see that they're in complex organic formations. Like they're in these polycyclic aromatic rings that are like, like glucose or benzene or all these kind of exotic formations. And we see them right now, like, they exist out there in the universe. They're being formed by natural processes.
Right, but you don't see, that's the thing though. Like, yes, they do exist. Yes, we may be able to see them, but we don't know that they were formed by natural processes. That's your interpretation. That's evolution's interpretation. So see, that's what I was saying, is that we both see facts. We both observe data. But then there's a line between science and our interpretation. And what you want to do is you want to erase the line on your side and make your interpretation a part of the science. But then you want to say yours has to have that solid line and you can't have it no matter what. And that's not how it works. We're both interpreting data based on what we believe. You believe it came from natural processes. I believe God created it. There's no way that you can prove it came from natural processes without redoing it. And you can't redo it in a biotic world. You have to go back to the biotic world to prove that, and you can't. So again, this is where we have a paradox. You have a question. We have a question that we're trying to get the answer to, but we can't get the question in the world we're in. We have to create a new world and redo it there, so to say. And maybe that's why they're trying to test certain things at CERN. But the whole moral of the story here is that until we can solid prove these theories in the conditions that they would have been in that stage of the universe, we can't prove them, because you can test things in today's world all day, but it's in today's world where things already exist, and we can go to the lab and grab a chemical and mix it in, and we can go out into nature and pick a leaf and dissect that leaf and take chemicals out of it. And there's things we can do in today's world that would not have existed in the previous stages of the universe. And that's what I'm saying, is that we're both taking interpretations and you're just trying to make yours a fact when it's not a fact.
Okay, so is your stance then that like the mechanisms of abiogenesis are like beyond just unknowable? Like, are you trying to say that there's like no possible like naturalistic process that could create life from non-life, or are you just saying that these things can never be known?
So I'm not saying we should stop trying to find the answers, but I'm saying in the world that we're in today, there's so many variables that would not exist previously that it seems like it is almost impossible to answer this question, because every article I've looked at where a synthetic chemist creates these proteins or creates these amino acids or puts them in a structure to make a building block, they're taking already existing chemicals that are purified bases in their lab and using these purified bases to create them. The thing is, in a prebiotic world, one, they wouldn't have been purified bases. They would have been mixed with everything else. Two, they wouldn't have the intelligence to put them together unless you want to start adhering to the creation model where there's an intelligent designer. And three, we don't see anywhere in the world today where it happens naturally out of nothing. Now, you said we can see lipids creating the bubble in the ocean, and then that bubble will create the building blocks. But again, the lipid has to be created first. And then your answer to that is, well, it came from the stars exploding, or it came from the sea vents, but we don't see them being created from scratch anywhere. So that's an assumption. That's an interpretation. The difference between interpretation and science is that science is something we can actually prove. And the thing is, we have to be able to, in order to test it, we have to be able to replicate the previous environment. So I guess, yes, to shorten everything down, and it is in a sense impossible to prove abiogenesis because we can't replicate those conditions, so to say.
Yeah, I don't know. I think that we can at least try to replicate the prebiotic conditions. I mean, that's what they're doing in origin of life research. I understand what you're saying is like, we can never know for sure if this is the prebiotic conditions, and these are controlled laboratory environments. So I understand what you're saying there. I'm not saying that we know the exact mechanism for abiogenesis by any means, but I think that we have seen lipids being formed in like by like hydrothermal vents. I mean, we have seen like amino acids occurring naturally in the universe. So a lot of these building blocks, I'm not seeing the big issue. I think that we have plenty of evidence that at least these building blocks are formed naturally. And I would just encourage anyone to check out the amyloid world hypothesis. That's one of my favorite ones, and it doesn't get enough attention in the media. So if you don't know it, check it out, do some research. And I like talking about these kinds of things a lot. So
For those watching, if you're a drinker, I would encourage you to come back and watch this episode. And every time he says, we don't know, take a drink. By the end of the live stream, you will have alcohol poisoning, because it's like every single thing we talk about. We don't know about this. We don't know about that. We don't know about this. But it's a fact because evolution. So that's it.
okay, so for everyone doing the drinking game, we don't know, we don't know, we don't know, we don't know, we don't know.